Which two sequences are more closely related, protein 1 and 2 or protein 1 and 3? Before doing anything, what do you think the answer is just by looking at them alone? And why? Who thinks 1 and 2 are more closely related? How about 1 and 3? Great, I would too. Spoilers, we're wrong. But it's because it's like 3 dots, right? 3 of them are exactly the same versus only 1 of them being exactly the same. But the important thing to note here is this one's that's exactly the same as tryptophan. Here, tryptophan got swapped by something. Probably not good. We already talked about when stuff is something like a cysteine that can participate in a disulfide bond or something very big or very charged. Generally, those swaps are not going to be good. So here's how we would go about actually deciding which one of these two is more closely related. So first, we need to look at substitution scores from our Blossom 62 matrix. So we would go, like I said, I know it's not here. Don't worry about it. We're going to do another example problem on the next slide. So you would go find alanine to methionine, and you would see that it has a score of -1. Then you'd compare the next spot. Grab all of the scores off of the matrix, sum them up. Okay? Get a sum of substitution scores. Now, this is only if you have a sequence that's longer than 1. I think the example problem just asks you to compare a 1-to-1 swap, so there's no summation. Okay? So here we have a sum of substitution scores on the bottom. So we could calculate the likelihood ratio, or Lij, for the entire sequence using the sum of summations here. Okay? So you could also calculate Lij for just this position. I think I took this off of the slide. Then just this position, then just this position, and you would multiply them. Okay? They have a multiplicative property if you want to go across. This figure is from your text. If you want to read it and do it that way, that's fine. I don't like to. What I like to do is take the sum of all of them and then plug that in and get my Lij. And if you want to prove to yourself that doing it 1 by 1 and multiplying them together versus taking the summed score and doing it gives you the same answer, I invite you to do that just to really confirm it for yourself. Okay? So if I want to get the likelihood substitution ratio, or this Lij term, for my top 2 sequences, 1 to 2, what do I do? How do I get to it? What do I do with 13? Divide by 2. How do I get out of log base 2? 2 to the power. Okay? I didn't really talk about this at all last semester, and then we got to the exam, and people didn't know how to get out of log base 2. I can't go through the properties of logs in class. We don't have time. Okay? But if you are unfamiliar, to get out of this and get Lij, we're going to divide both sides by 2, and then we're going to take 2 raised to the power. Okay? This will get rid of the log. 2 raised to 13 over 2 is about 90.5. Okay? Like I said, I can't prove the math. You just got to use logs in this class. Okay? So here we have a likelihood ratio of 2. Proteins 1 and 2 are more closely related by about 45 times. Okay? The likelihood of this substitution here has a ratio of about 90.5. Remember, we said when our L score is greater than 1, it's way, way more likely than random chance. 1 is chance, and less than 1 is it's not very likely that would happen. Here, our score was only 2. Pretty close to 1, pretty close to random chance. Way more likely that 1 and 2 are related than 1 and 3. And it doesn't really follow based on just looking at perfect matches. Does the Blossom matrix make sense chemically? It does. This figure goes through a couple different scores for you. So it talks about keeping tryptophan the same. If you were to replace it with tyrosine, which is somewhat similar, if you replace it with proline, you're actually getting this less than 1 likelihood score. You'll get a negative substitution for these two. It follows chemically, but we need the matrix to really trust those numbers quantitatively.